we are given a function x squared minus 4x minus 5. We can tell it's a quadratic function because it's got the x squared term. It says find the axis of symmetry. Well, in order to do that, we have to know what a and b are. Well, a is, in this case, what is a? You can tell me. Raise your hand, somebody. Someone raise your hand. Slope? No. No? No? What's a? Yes, ma'am. 1. A is 1. Very good. All right. And b is, what would you say, Miss Turner? -4. Good job. And c in this case is -5. We don't need that right now. It's saying find the axis of symmetry. Well, the axis of symmetry is always at the x component of the vertex. The x component of the vertex is found at -b over 2a. Okay, so the axis of symmetry is -b over 2a, which is the x component of the vertex. So we plug in b and a. So we get -4 here, and a is 1. There's a negative times a negative, so that makes it positive. Positive 4 over 2 times 1 is 2, so that equals 2. So the axis of symmetry is at x equals 2. Does that make sense? And then it says find the vertex. But the vertex, what's the x component of the vertex? There's two components, the x and the y. What's the x component of the vertex? What was that? What goes here? 2. 2. 2 goes there. That's because the x component of the vertex is the same thing as the axis of symmetry. Okay, it's at the same place as the axis of symmetry because the axis of symmetry always goes through the vertex. Now, if we want to find the y component, what do we do with that? Plug it in. Exactly. So we get 2 squared minus 4 times 2. 2 squared is 4, minus 4 times 2 is 8. 4 minus 8 is -4, minus 5 is -9. So we plug that in. Once again, I've got to pray. You know, the Lord helps us even if we don't ask Him to. But we should always ask. So let's pray. Let's pray. Lord, we know that without your strength, this entire universe would cease to exist. We know without you there is no good, there is no love, there is no peace. But with you there is love, peace, and joy beyond our imagination. Lord, I ask that you lend that to us. Bestow your grace upon this class. Bless us in our time. Help me to teach, help the students to learn. Help us all come closer to you. We love you, Jesus. Okay, so we got our vertexes at 2, -9. Find the y-intercept. Okay. What do we know about the x value of any function at its y-intercept? The x value is always what at its y-intercept? 0. So if we know the x value is always 0, what should we plug into our function to find the y-intercept? 0. I don't know why they've got plus as -5 here. I don't know. But 0 minus 0 plus -5 is the y-intercept is -5. So the graph passes through 0, -5. Okay, so we've gotten the vertex, we've got the axis of symmetry, and now we have the y-intercept. So if you turn to the next page, we'll plot those. So we start with the vertex, we plot it at 2, -9. That's here. Then we go ahead and plot the axis of symmetry, which always goes through the vertex, which at this case is at x equals 2. Then we plot the only other point that we have at the moment, which is our y-intercept at 0, -5. And that's what we have so far. Now, how it continues on, it asks you to graph things in a way that's a little bit different than how I would have you graph it, but it's worthy to look at how they're asking you to do it. In step D, it says, find 2 more points on the same side of the axis of symmetry as the y-intercept. So here's the y-intercept, and we can see that the y-intercept is on the left-hand side of the axis of symmetry. So what it's asking us to do is find 2 more points on this same side. And so what it says is, okay, well, let's start with x equals 1. And if you find x equals 1, yes, that's also on the left side of the axis of symmetry. So let's find its point by plugging in x equals 1 into the equation. So that's 1 squared minus 4 times 1 minus 5, or 1 minus 4 minus 5. 1 minus 4 is -3, subtract 5 is -8. So the point is 1, -8. And once we've determined that point, we can go ahead and plot it. 1, -8. And now it continues on and it says find another point at x equals -1. And insert, as we can see, x equals -1 is also on the left side of the axis of symmetry. So let's go ahead and plug that in. -1 squared minus 4 times -1. -1 squared is 1. 4 times -1 is -4. 1 minus -4 is the same as 1 plus 4, so it's 5 minus 5 is 0. And we get our point here, -1, 0. And there you go. So our result clearly is half of a parabola. Right? We only have the half on the left-hand side of the axis of symmetry. But what do we know about a parabola and its axis of symmetry? What's the relationship? That parabola is what about the axis of symmetry? It's right there in the name. It's symmetric. It's symmetric about the axis of symmetry. So what it asks us to do in step E is it says reflect the graphed points over the axis of symmetry to create 3 more points. So because this is kind of like a mirror, we'll reflect it over the axis of symmetry, and that's how we'll get the rest of our points in our parabola. So by symmetry, because we know it's symmetric, we don't have to find these points. We know where they should be. And once we have that, we go ahead and graph our parabola. Now, I want you guys to notice something. What they've done is the graphical way of doing what I have shown you in a table. I think that doing it in a table is more simple. You may disagree, but I'll show you how I would have done it. How I would have done it is once I got this vertex at 2, -9, I would have created my x f of x table. You guys remember this? Once I got my vertex, I would create my x f of x table, 2, -9. Then I'd choose the points 1 and 0. And at 1, I would have found out that it was -8. And at 0, I would have found out it was -5. And then I would have gone ahead, and by symmetry, I would have gotten my other points. You see that? Does that make sense? So it's the same exact thing. By symmetry, the reflecting points about the axis of symmetry. By symmetry, I only have to get these 2 points, and then I know that these 2 will be the same. Does that make sense to you guys? It's basically the exact same process, except how I'm doing it is I'm creating a table first, and then I would go ahead and plot the values. Does that make sense to you guys? Any questions on that? Good? Solid? Good? Is that confusing? No? Okay. Just got to find it like that. That's a great shirt, by the way. Nice. What a great theme for homecoming. Discussion. Why is it important to find additional points before graphing a quadratic function? Why should you find the most amount of points possible? It's a simple question. What? Yeah, just to be more accurate. Okay. You can write that down if you'd like. Now, the meat and potatoes of this lesson is what we're getting into now. Using zeros to solve quadratic equations graphically. But before we go on, let's just recap. What did we do? We graphed this quadratic function in standard form. Okay. So now we are going to use zeros to solve equations, quadratic equations, graphically. So what's the main idea? We might have a quadratic equation. And a quadratic equation is like a quadratic function except it's got an equal sign. So a quadratic equation could be like the situation they give us here. 2x squared minus 5 equals negative 3. Now if I just gave this equation to you and I said solve for x, you would have to do some form of algebra to figure out exactly what x is, right? You'd have to do something and you'd figure out what x is. Eventually, with quadratic equations, we will be doing exactly that. We will be using algebra to solve for x. In fact, most of you guys can solve quadratic equations already, or at least kind of remember how to factor to solve and how to use quadratic formulas to solve, okay? So eventually we're going to get back into that, but for now, what we're going to do is we're going to solve these equations graphically. And we're going to do that by finding the zeros. Remember what we went through the last time? We talked about the zeros of the function. So in order to do this, we have to start by adding 3 to both sides. And we end up with 2x squared minus 2 equals 0. And that's exactly what it says here in your book. It says step A is to write the related function. We add 3 to both sides to get 2x squared minus 2 equals 0. And the related function is this left-hand side, 2x squared minus 2. Okay? So what I have here is a function that equals 0. And if I'm going to graph it, the solutions of this equation are the zeros of the function. Okay, now let me say that a little bit more clearly. The zeros of this function, when I graph it, are when the function is equal to 0. So to solve for x in this occasion, when the function is equal to 0, I just have to find the zeros of the function. Does that make sense to you guys? Is that pretty clear? So what they go ahead and they do is they plot the points, and they notice that the zeros are where? Where are the zeros of this function? Ariana? On the x-axis, but where are the 2 points? Negative 1 and 1. So the zeros of this function are where the function is equal to 0 at the x-intercepts. Those are my zeros right here, right? So what that means is these zeros at negative 1 and 1 are where this function is equal to 0. So the solutions of this equation are negative 1 and 1. Does that make sense? So I found the solutions of this equation graphically. Is this making sense to you guys? Okay. And as we see, look, if we plug in negative 1, 2 times negative 1 squared minus 2, well, negative 1 squared is 1, so it's 2 minus 2, which equals 0. So yes, negative 1 is a solution. And if I plug in 1, it's 2 times 1 squared minus 2 equals 2 minus 2 equals 0. So yes, 1 is a solution as well. Does that make sense? So I was able to find the solutions to this equation here graphically. Okay, any questions about that? No. All right. So we're going to go ahead and do part B now, and then you're going to have a chance to do it on your own. So part B. we have this equation, 6x plus 8 equals negative x squared. But I have to get a 0 on one side, so in order to do that, I'm going to add x squared to both sides. And I end up with x squared plus 6x plus 8 equals 0. See? And that's a quadratic function that equals 0. The related function is y equals x squared plus 6x plus 8. Now, if I want to graph this function, they've already determined my points here. Okay. All I have to do is plug in those points. Usually, we would have had to find the vertex to find the center point, right? You guys remember that? But they've already found the vertex for us. So let's plug in the points. Negative 5 squared is 25. Minus 5 times 6 is 30. So 25 minus 30 is negative 5. Plus 8 is 3. Negative 4 squared is 16. Minus 24 is negative 8. Plus 8 is 0. Negative 3 squared is 9. Minus 18 is negative 9. Plus 8 is negative 1. And then by symmetry, we can fill in the rest of these points. Now, do I have to graph this function to see where the zeros are? No, they're right there. X equals negative 4 and x equals negative 2, but let's check it. Negative 5, 3. Negative 4, 0. Negative 3, negative 1. Negative 2, 0. Negative 1, 3. So there you go. There's our function. And it's clear that our zeros are right here at negative 4 and negative 2. Well, there you go. There are zeros, negative 4, 0, and negative 2, 0. So where are the zeros of the function? Negative 4 and negative 2. So the solutions of this equation are negative 4 and negative 2. Does that make sense to you guys? So we're finding the solutions of a quadratic equation by graphing the related quadratic function. Okay? Is that pretty clear? Okay. All right, so go ahead and do number 3 on your own. Number 3 at the bottom of the page, 261. What's the point here? Finding the equation first, setting one side equal to 0. Get the vertex, create your table, use that table to find your zeros and graph your function. Okay, let's give it a shot. First, I have to get one side equal to 0, so I'll add 3 to both sides. I end up with x squared minus 1 equals 0. Now remember, standard form is ax squared plus bx plus c. And vertex form is a times x minus h squared plus k. In this case, either one will work because I don't have an x term. So it's not clear which form this is. Okay? So if it was in standard form, then it would be 1x squared plus 0x minus 1. You see that? Because there's no x term. Okay? And so in that case, a would be equal to 1 and b would be equal to 0. Does that make sense to you guys? So when we're finding our vertex, remember our vertex is at negative b over 2a. Well, that's just negative 0 over 2 times 1. Well, that's just 0. So that's the x component of our vertex. But we find the y component by plugging in 0 into our equation here. So we get 0 squared minus 1 equals negative 1. So our vertex is at 0, negative 1. Does that make sense to you guys? Do you understand? We found our vertex by doing negative b over 2a and then plugging that result back into the equation. Once we have our vertex, we create our table, x, f of x. We start at 0, negative 1, then go down 1, 2, up 1, 2. If I plug in negative 1, negative 1 squared minus 1 equals 1 minus 1, which is 0. If I plug in negative 2, it's negative 2 squared is 4 minus 1 is 3. And by symmetry, I have this. Now, do I need to graph it to find my zeros? No. They're right there, where the function is equal to 0. But let's go ahead and graph it anyway. If I graph it, it's negative 2, 3, negative 1, 0, 0, negative 1, 1, 0, 2, 3. And there's my function. And I can see that the zeros of this function are right there. So what are the zeros of my function? The zeros of my function are x equals negative 1 and x equals 1. That's where my function is equal to 0. Does that make sense? So those are the zeros of my function. So what did I do? I just solved this equation. X squared minus 1 equals 0. What are the solutions of that equation? Solutions of that equation are negative 1 and 1. Does that make sense to you guys? Yes, ma'am. How did I find the solutions? Well, I found my vertex, then I created my table by going down 1, 2, up 1, 2. The solutions are the x values where the function is equal to 0. You see, because that's exactly what the zeros of the function are, where the function is equal to 0. You see? And I found that's at negative 1 and 1. And because of the way I did this, those are the solutions to my equation. Does that make sense? Now, here's where your book and I differ a little bit. Okay? Your book tells you to do something that I'm not going to do. Let's do this one exactly the way we did the other one. All right. So I had this equation, right? Well, what I need to do is come up with the related function. Well, the related function is 2 times x minus 4 squared minus 2, right? And then I need to find the zeros of this function, and the zeros of this function will be the solutions of this equation. Does that make sense? Do you guys understand that that is the main idea that I'm presenting to you today? The zeros of this function are the solutions of this equation. Why? Because that's the function set equal to 0. Does that make sense? So if I can get a quadratic function equals to 0, and I can graph that function, then the zeros of that function are the solutions to that equation. Does that make sense to you guys? Yeah? Okay. So the first place I start with, as always, when I'm graphing a function is the vertex. The vertex is at 4, negative 2. And then create my x, f of x table. Here's my vertex at 4, negative 2. I go down 1, 2, up 1, 2, and I plug in. Plugging in 3, I'm just going to go quickly. 3 minus 4 is negative 1, squared is 1, times 2 is 2, minus 2 is 0. 2 minus 4 is negative 2, squared is 4, times 2 is 8, minus 2 is 6. By symmetry, 0, 6. Do I need to graph it to find my zeros? No. There they are, right there. So the solutions of this equation are x equals 3 and 5. Does that make sense to you guys? Okay. And just to prove it, use Desmos. There you go. There are my zeros at 3 and 5. Does that make sense? You guys see? Okay. So those are solutions to my equation. What's that website where you can type in a math equation and they give you the answers? Mathway? Do I have to have an account? No, right? I don't, right? Let's see if I can just copy it. Oh, that did not work. 2 x minus 4 squared minus 2 equals 0. Solve for x. I have to scroll down. Solve for x. Isolate x equals 5 and 3. Hey, there you go. 3 and 5. You see? Okay, you see? Okay. So the solutions of that equation are the zeros of the function. Does that make sense to you guys? All right. Now, let's take it a step further, modeling a real-world problem. Our squirrel friend is going to lend us his mathematical genius. We read where it says nature. A squirrel is in a tree holding a chestnut at a height of 46 feet above the ground. Okay, let's draw our picture here. So here's the ground. Here's our tree. Little branch here. And here's our squirrel friend. Okay, and he's holding a chestnut. There's his chestnut. And he's holding it 46 feet above the ground. Okay, that's the situation. You guys with it? Yeah? Okay. It drops the chestnut, which lands on top of a bush that is 36 feet below the squirrel. Let's draw our picture. Here's our bush. It's 36 feet below the squirrel. Okay. The function h of t equals negative 16t squared plus 46 gives the height in feet of the chestnut as it falls. So the height of the chestnut as it falls is h, where t represents time in seconds. It doesn't say in seconds, but it is in seconds. It says, when will the chestnut reach the top of the bush? Okay, I accept your challenge, Mr. Squirrel. Here's my equation. And it says, when will the chestnut reach the top of the bush? Well, h is the height of the chestnut, right? Well, what will the height of the chestnut be when it reaches the top of the bush? 46, 36, what? 10. Why is it 10? Yeah. 46 minus 36. That bush is 10 feet tall. Very good. Bush is 10 feet tall. So I know that when it falls, when it hits that bush, h will be equal to 10, right? Well, what is it asking for? It says, when will the chestnut reach the top of the bush? When implies what? Time. So it's saying, what will time be equal to when h is 10? Well, I have this equation. I have h. I'm solving for time. What should I do? Plug in 10 for h. We get 10 equals negative 16 t squared plus 46. I have a quadratic equation here. I have to solve this quadratic equation for t. Okay? What should my first step be? I've got it equals to 10. What should it be equal to? 0. So what should I do? Subtract 10 from both sides. And I end up with negative 16t squared plus 36 equals 0. Good. So there is my function, my equation. Now I have to get my related function, right? Well, my related function is just this part, right? And what should I do with this function now? What should I do with it? Figure it out, yeah? How do I figure out the zeros? What have we been doing this whole time to find the zeros? We graph it. We graph it. Now here's the thing, okay? Not every time am I going to be able to create a table and find the solutions in the table. I was kind of pulling a veil over your eyes and suggesting that that was possible. It's not always possible. Because maybe the values of x, or t in this case, that I plug into the table, into my function, are not correct. For instance, what if in this case here, it wasn't negative 1, but negative 0.9? Well, then I never would have found it, right? Does that make sense to you? I never would have found the 0. So I can't always just create a table and think I'm going to get the solution. Does that make sense to you? I'm not always going to be able to get the solution that way. So if I'm not always going to be able to get the solution that way, the question is, how do I get the solution by graphing? What do I need to use? What do I need to use?
Formula.
Praise God, yes, eventually. But for now, if I'm doing it by graphing and I'm not going to be able to graph it by hand, I need to use technology. I need to use technology. And well, on the test there wouldn't be one that you couldn't use like this. I would ask you, for instance, just find the function, and then I would give you some kind of way that you wouldn't have to use it. Does that make sense? Okay. But shh. Or maybe, yes, okay, got it? So look, I have to plug this function in. Now here's the problem. Desmos does not like t. If you plug in t, Desmos is clearly not British. Got it. Nice. It doesn't like t. It wants you to put in x. It wants you to put in x. So you use x. And then bam, there's your 0. Why? Look, there's another 0, negative 1.5. Why would it not be negative 1.5? What does that imply? You went backwards in time and the chestnut hit the bush and then came, who knows? It's not negative, it's positive. So your answer is 1.5. So the answer is t equals 1.5. You found that solution by graphing. On your homework, you used Desmos. Does that make sense? Now, which gives your next point of conversation, which is, what is your homework? Your homework is page 267, numbers 1 through 16. Now look, everyone carefully, shh. All of these you do by hand, okay? Numbers 13 through 16 use Desmos, okay? D-E-S-M-O-S. All right, that's it. Any questions? Yeah.
Wait, so it's 1 through 16?
1 through 16. Your homework, page 267, numbers 1 through 16. All right, any questions? It's up on my system.